12.4. So we were doing logarithmic properties. So today first we're going to start with is the product rule of logarithms. The product rule of logarithms. What does a product rule say? If you have log some base m, if you have log and there is some base b m, and that you add log with the same base n. Note my basis is the same and you are adding log base m plus log base n. Then what you can do is you can combine it. It becomes log base. Note my base will still remain the same, but addition changes into multiplication. You can combine it and it will change into multiplication. Okay, example, it says express as an equivalent expression that is sum of logarithms, and you are given log 2 4 times 16. You have to write this as a sum of two logs. So you should, here I have just one log. They want you to write as a sum of two logs. Since it is multiplication, it's multiply 4 times 16. You're multiplying. You can separate them. Multiplication will change into addition. So it becomes log 2 4 plus log 2 16. My base will still remain the same. Make sure to write the base. Very important thing. Don't forget to write the base. Your base will still remain log 2 and multiplication will change into addition. Okay. If we have to simplify this, okay, Christina?
Yes.
Okay, Christina. Log 2 4. Can you simplify this?
I have to go back and look at what we did. It will be 2 to the fourth power, is it?
Factors
or
of,
the to the second power. Sorry.
Yeah, 2 to the second power. And what is log 2 to the power of 2?
Sorry, I can't remember what we did last week.
It's okay. So we did a property where it said log base, and if this base is raised to power m, and remember my log is some base, and here I also have the same number, and that thing has some power. Basically, they cancel. You are left with just m.
Oh yeah. So then it would just be 2, right?
It will just be 2. And what about here? 16. Let's make factors of 16. What are the factors?
4 and 4.
4 and 4. And 4 is 2 times 2, right? 2 times 2. So what do you get? 2 times what?
2 times 2 times 2 times 2.
So 2 to the power of?
4.
4. And what will be the answer? 2 plus?
4.
4, which is?
6.
6. If they ask you to simplify, since they're asking you to just write it, so you're going to leave your answer there. But if you have to simplify, that's how you simplify. Okay, let's do one more problem here. Log, you're given 10 times 1000. You have to write it as the sum of logarithms. Martin?
Yes.
If I have to write this as a sum of logarithms, how will you write it?
Log 10.
Log 10?
10.
Okay. Then it's?
Plus.
Plus, okay.
Log 10 of 1000.
Perfect. If they ask you leave here answer, leave as it is. But if they ask you to simplify, you simplify. What is log 10 10, Martin?
It would be
We did one more
uh,
property, log base. If you have the same
yeah,
numbers, they both are same, then it's equal to
10.
1 1.
Oh, yes.
So now you have 10 10. So it becomes what?
1.
1 plus. Okay, log 10. How can you write 1000 as? Can you write 1000 as 10 to the power of something?
Yes, 10 to the power of 5, I think.
How many times should I multiply 10 to get 1000?
100.
See, let's say make factors of 1000. Let's see. If you divide 1000 by 10, what do you get? 100, right? What are the factors of 100? You divide by 10, what do you get? What is 100 divided by 10?
10.
10. So how many tens I'm getting?
100.
See here, see how many tens? 1 here. So 1000 first I divided by 10, I got 10 and 100.
3.
3. 10 to the power of 3.
3.
And what is log 10, 10 to the power of 3?
$1,000.
Compare this property here. See here. Log base to the power of m. See here. Compare this property here.
1.
It is to the power. It becomes this power 3. When your base and this thing is exactly the same, they basically cancel out and you're left with just 3.
3 then. Okay.
So you get 4 as your answer.
So the answer is 4.
Yes. Let me see. We did all these. Let me see what properties. Okay. So before we do questions, maybe you want to write the notes for yourself. Okay. So the properties we did so far is log. If you want to make a note, we did properties these last time. Log, no matter what my base is, log base 1 will be 0. So if I say example, I say log base, or I say log 2 1, what's the value? It should be 0. No matter what my base is, it will always be equal to 0. If I say just log 1, that is also equal to 0. So no matter what my base is, log 1 is always equal to 0. That's what we did one of the properties last time. This was the first property. Second property we did was, if you have log base, my here base and this number, they are exactly the same. That will be equal to 1 all the time. Example, if you have log 10 10, my base and here number, they are exactly the same, then it comes out to be equal to 1. You don't have to solve. Example here, log 2 2, it will always be equal to 1. This is another property we did here. When I say log 10, I say log m, when there is no base, there is actually a base, which is 10. So if there is nothing written, that means there is 10 there in the base. Okay. The next thing we did about is natural log. which is basically ln. It is known as ln. And what does ln mean is it is log with base e. It is log base e. We did this thing. Next thing we did in the previous lecture was if you have log base to the power of m. So whatever was your base, if your base was 10 and then you have 10 to the power of something, basically they cancel out and you're left with your power m. So these are the 5 properties we did in the previous lecture, and we are using these properties to do problems right now.
I have a question
Yeah.
about the number 3, property 3.
Yeah.
So if it's just a number and it doesn't have a base to the log, it ends up just being 10.
Yes.
Okay.
So example, if I say here, Jordan, I say log 1000. Okay, what is log 1000? I just say find log 1000. Okay, what does it
be log to the base 10 and then 1000?
1000. And how can you write 1000 as?
10 to the third power.
And can you use any other property to solve this further?
I guess you could put it into a...
See, your base and this is same, right? Log 10, and then this same base is raised to some power. Right?
Okay, so does that just make it 3?
Yes, exactly.
Okay.
You got it, yes. Similarly, if I write
Wait.
ln, that means log is base is e. Yeah.
What is it inside of the parentheses for number 4?
Number 4, it says L, and N, ln. It is known as
All right.
natural log.
Thank you.
Yeah, no problem. So these are the properties we have done so far before already. Now we're going to use these to solve. Okay. Now before, what we were doing is a problem we did before, we were expanding. We were given 1 log, we were expanding it into 2 logs. Now we'll be given 2 logs and we'll be combining it into 1 log. So the question will say, express as an equivalent expression that is a single logarithm. So you have to convert into 1 now. So you are given problem like log base 7 plus log base 5. Now note, log base 7 plus log base 5. Since my base, first thing you have to check, is your base the same? Yes, my base is the same. Both have b. Okay. And they are adding. Since they are adding changes into, I can combine and it will change into multiplication. It becomes 7 times 5, which is log base 7 times 5 is 35. Let's do one more example. You are given log 3x plus log 3y. You have to combine it. Savannah? Not here. Carlos? Not here. Chanton? Not here.
Yes.
Oh,
Hello?
Hello, Chanton. Yes. Can you combine and tell me? Can I combine these first of all?
Yes.
Because
they
my
have
base
the
is
same
the
base.
same. Yes, exactly. Okay, so I can combine. When I combine, what does it become?
Log 3.
Mm-hmm.
And then you're going to multiply the x and the y.
So it
So it's
becomes
just going to be xy.
That's it. You cannot solve further, so it's just xy. Before I go
But if
further,
the bases were different, then we can't do
You
the
leave it.
multiplication, right?
yes, you leave your answer there only then.
Okay.
Yeah, your base has to be same. Let's do more problems on this. So you need to expand. You need to expand. Okay, let's do one more problem here. You are given log 381 times 27. Log 381 times 27. They're just saying expand. Okay, equivalent expression you have to write. Jordan,
Which Jordan?
you. Yeah.
Okay. Just let me write it down.
Yeah.
So for expanding, am I just gonna break it up into like the addition?
Yes. Because it's multiplication, you can do that. Yes.
Okay, so would it be log 3 and then is it log 3 to the power of 81.27?
No. It's not point. It 81 times 27.
Oh, 81 times 27. Okay, so could it be log 3 to the power of 81 plus log 3 to the power of 27?
Okay. You're saying it correct, but it is not par. It is not par.
What is it?
You just write log 381. It has base this thing, but this is not the par. It is a number next to log.
Okay,
Yeah.
just a number.
So you just say it like this: log 381 plus log 327.
Okay.
Yeah. Let's do one
Right.
more example. Sabrina,
Yes.
okay, Sabrina. So you have question as log, you given 2 16 times 32.
Excuse me, real quick. Log 2 16 times what? Oh, 32.
Yeah, times 32.
That would be log 2 16.
Mm-hmm.
That's how you say it, right?
Yeah, you're saying it correct, yeah.
Log 2 16 plus log 2 32.
Perfect. Really good. Savannah?
Sorry, I didn't mean to interrupt. I just wanted to kind of reiterate. So when it says expand on like my math lab or on a test or something, it just means to like separate it
Yes.
on the other side of the equal sign, right? Like we're not solving it at all.
The thing is, the question will say like this. It will say express as an equivalent expression that is sum of log rhythms.
Okay.
Because you just
Thank you.
doing it as a sum. That's what it will say. That means you just have to separate them. You don't have to solve it.
Okay, thank you.
Yeah.
Sometimes just with my math lab, it can get kind of confusing. So
Yeah,
Yeah,
I'm glad you
thank
asked
you.
that. That's good. If they say just expand, that's it.
okay, thank you.
Also, Savannah, you have to answer this question.
Oh,
You have
okay.
log 464 times 16.
So you would do log 4, and then 64 plus log 4 16.
Correct. Okay. Daniela,
Yeah.
so you have log t 3ab.
It'll be, is that a J or
T. This is t, and then this is
Oh, is it-
3ab.
Oh, it's a T. Okay. Okay, so log T 3
Mm-hmm.
plus log
Mm-hmm.
T A B.
AB also are multiplying each other, right?
Yeah.
You can separate them also.
So plus log T B.
Yes, correct. So whatever is multiplying, you can separate them. How many? If 3 are multiplying, separate 3 by addition sign.
Okay.
Yeah, good. Daniel.
I
Okay.
had a question.
Yeah, Jordan.
So kind of like what Savannah was saying earlier about the tests and stuff. Well, actually, I was going to go on a little different pathway about it, but so when you're grading it, and you know, like if we were in person, you'd be able to mark what we did wrong, and then we'd be able to get it back and understand that. But since it's a little different, it's kind of hard to learn like what we did wrong based off of just my Pearson lab. So I was just wondering, do we get stuff back of like what we did wrong?
The thing is, I was not planning to do it, but if you want, because I just checked online, I don't do it physically, I don't print it out and do it.
Okay.
So
Because just like in my previous math classes, is like, let's say there's a 5-point question and you were able to get 3 of the parts right, you'd be able to get 3 out of 5. Except like on my Pearson math lab, if you do one thing wrong or don't put a comma, you get the whole question wrong, and it's like you lose 5 points.
I'll see that. I can see that if I can send you the work, because I checked it, but yeah, I can see if I can do that. Okay.
Okay.
Yeah.
Thank you.
Yeah. Okay. So this was when you are expanding it. You are expressing it as 2 logarithms. Other kind of question you can get is express as an equivalent expression that is a single logarithm. So rather than 2, they want only 1 in your final answer. So example, so if you have log a2 plus log a10, you have to combine a. You have to combine them into 1 log. You have to combine them into 1 log. Is Brian here? No, Brian is not here. Jose?
Yeah.
So Jose, how do you combine?
So would it be log 20? Log A20?
Log A20. So it's 2 times 10, which becomes log A20, correct. And I can combine, again I can combine only because my base is the same. If my base is not the same, I cannot combine. Okay, Gerardo? Rockwell?
Yes.
So you have log TH plus log TM.
Okay. So it's going to be log T, and then in parentheses H times M.
Yes, exactly, which becomes log THM.
Oh, yeah, log THM.
Yeah, perfect, yes. So this is how you use the product rule. So far what we have done right now is known as the product rule. Next thing we're going to do is quotient rule. Is there no proof, right? Yes. Next thing we're going to use is quotient rule. What does quotient rule say is, so when you have log base, now it's dividing. If they were multiplying, you separated them and added. You were separating them and you were adding them when they were multiplying. When you had m times n, it changed into a log base m plus log base n. But in this case, m and n, they are dividing each other. So in this case, my base will still remain the same. It will become log base, the numerator, that means the top one, minus log base, the denominator, the bottom one. So division changes into subtraction. Multiplication changes into addition. Division changes into subtraction. So it will become log base m minus log base n. So the question on this again you will get is, it will say express as an equivalent expression that is a difference of logarithms. So now you have more logarithms. You have to do it in the form of differentiation. So example, if I say, what is log t 6 divided by u? I say find the value of log t 6 divided by u. Since it's division, remember multiplication changes into addition, division changes into subtraction. Log, my base will remain the same. If it's t, it will remain t. First will be the top one, log base 6. Then you will put a minus sign. Then log, my base will still remain t, and the denominator u. So that's your answer. Log t 6 minus log t u. Let's do more questions on this. So if you have, like, let's for example, one more.
Hey, Professor, real
Yeah.
quick, can you just put the paper back really quick?
Yes.
Thank you.
Yeah. Is Dylan here?
Yes, I'm here.
Okay. Dylan, help me solve this one. So you're given log 2 5 over 11.
So that would be log 2 5 minus log 2 11.
Yes, correct. That's it. Julian,
Yes.
so you have log b m divided by n.
So it would be log b m minus log b n.
Correct. Caesar,
Caesar.
so you have log a y over x.
Log a y minus log ax.
Yes, correct. So that's how division changes into subtraction, multiplication changes into addition. Okay, another kind of question you can get on these kind of problems is, it says express as an equivalent expression that is a single logarithm. So into 1, you have to combine them into 1. So example, if you're given log a 19 minus log a 2. Cat?
Yeah,
Okay, let's see. If you combine them, what does it become?
give me 1 second. Let me finish writing it down. So,
I have to combine into 1. Now, subtraction will change into what?
would it change into a fraction?
Yes. So what does it become? You're correct.
Would it be log a 19 over 2?
Correct. Absolutely correct. Yes, that's it. Really good. Let's do one more problem. So you have log b 36 minus log b 4. Okay, can I have Jordan? Paulo. Lauren?
Yes,
So log b 36 minus log b 4.
that's going to equal log b 36 over 4 in parentheses.
Can you divide that?
Oh,
mean, don't-
yes.
I mean, you don't have to solve, leave
That
it.
can simplify to 12
9. Log b 9.
or 9. Sorry.
Nine. I mean, if you just leave your answer there, don't solve. Okay, don't solve. Yeah.
Okay.
Yeah. Okay, let's do one more problem before I go further. So you have log a x minus log a y. Brett?
Yeah, I'm here. Would it be log a x over y?
Yes, correct. Perfect. And everyone make sure I can combine only if my bases are the same. If I have here log a x minus log b y, I cannot combine. Then you write no solution. You can only combine only if your bases are the same. They have to be the same, only then you can combine. So these were the product and the quotient rule. The next property is known as the power rule of logarithms. Power rule of logarithms. What does a power rule say? If you have log base b and then you have m to the power of p. Since it says the power rule, whenever there is a power in the logarithms, what does it do is, it will pick up this p. This is the power. It will pick up this p and throw it in front. So it will become p log bm. So what does log does is, it picks up the p power and throws it in front. I can throw it back in the power, whatever is in front of the log. So this is the power rule. Example on this is, let's see here. The question says, use the power rule for logarithms to write an equivalent expression that is a product. You have to use a power rule for logarithms to write the equivalent expression that is a product. So basically, if they say example, log a, you have 9 to the power of negative 5. Product means multiplication. So whenever product is just another name for multiplication. Whenever you have to use power rule in this thing, what you're going to do is, whatever is in the power, pick this up and throw in front. It becomes negative 5 log a 9. Everything else remains the same. Okay, let's do one more example here. Can I have Jesus?
Yeah.
Okay, so you are given, you're given log 7, you're given cube root of x. But how can you write the cube root? X to the power of what?
1/3.
1/3, yes. And if I use power rule, what does it become?
1/3 log 7 x.
That's it, yes, correct. That's it, that's your answer. Remember guys, whenever you have nth root, it becomes equal to 1 over n power. We have done this property. Nth root becomes 1 to the n power. Let's do more examples on this thing. Power rule. Let me see, they have. Okay. So you have log a r to the power of 8. Log a r to the power of Fernando.
Yes.
Okay. How do you write this one?
So it would be 8 log a, and then
R. That's R.
pi, whatever. Okay, yeah.
R.
The r.
Yeah. So that's your answer. Okay, let's do one more problem on this. So if you have log c m to the power of -5. Niza? Yasmin? Maria? Josue?
Yes.
Okay. How do you write this one?
-5 log c m. Wait.
That's it. Good. Okay. So these are the 3 properties we did use so far. Now next thing we are doing is using the properties. This is how basically you're going to get the question in a final exam. Using the properties together. So all the properties we have done so far, we're going to use all the properties and use them together. So if you have example, if I say log b x cube over y z, I have this thing, log x cube over y z. In this case, first I see is log base, okay, yeah, log base, you have x cube is divided by yz. So in this case, what you're gonna do is, so you have log division. Okay, let's see, can I have Anthony here? Okay, can I have Christina?
Yeah.
So we have done 3 properties so far. Quotient
Yes.
rule, product rule, and power rule. Which property would you like to use first?
Well, first we're going to do the log b x cubed minus log b y to the z.
Perfect, because they are, what do you call, your question, they're dividing. First thing is dividing, perfect, you separated them. Then?
And then we'll do the power one. So it'll be 3 log b x. Is that y to the z or just yz?
Yz.
Oh, then we will do the so minus log b. Sorry, just going back to my notes. It will be y plus log b z.
Okay, you did correct, you're not wrong. But guys, here, this is important step here. I want you to mark this step, very important. After a negative sign, whenever you are expanding, make sure you put in a bracket.
Okay.
Very important step. Make sure you put in a bracket. If you don't put in a bracket, your answer will be wrong. Okay. The reason is, so when you open the bracket, what does it become, Christina?
It'll be minus log by minus log bz.
Exactly. So both will be negative, not just one. After, again I repeat, after the negative sign, if you are expanding, you are making it bigger into 2, make sure you put in a bracket. Very important step. Definitely, I am giving you already, definitely 100% on the exam you're getting question like this, in your final exam also, plus in your test also. where you have to expand after the negative sign. And you have to remember this, that you put in a bracket. Okay, let's do one more example.
For the final answer, does it need to be in a bracket? This is not in the bracket there. But...
No, you have to open it.
Okay.
This will be the final answer.
So for the final answer, though, it doesn't have the bracket because you already opened it up.
Yes. Okay. Let's do one more example. If you have log a 4th root of xy over z cube. Log 4th root of xy over z cube. Savannah?
Okay, give me 1 second.
Yeah.
Okay. So
first, I don't want roots. I don't want this root. How can I write root?
Yeah. So you would turn it into log xy, or I guess log x 1 over 4.
No, you write it like this, xy.
Okay, so you do. Okay.
And this whole thing is inside, right?
With the power 1 over 4 on the outside of the parentheses.
Okay. Then?
And then you would do, to break it down, so you do equals log x.
See here, Savannah, first thing. Okay, you are doing it correct. But first thing you see is this whole thing. The difference between these two is here only x had power 3. Right? Here this whole thing has power this thing.
Yeah.
So first you need to get rid of this whole thing.
Okay.
So what does it
So would you distribute the 1 over 4, like, because it's xy and that's multiplication, should I split that up so I'd get like log a x 1 over 4 plus log a
you
y
can do
1
that.
over 4?
Yes.
Or minus, minus because it's...
Yeah, 1 over 4 and this will become 3 over 4.
Yeah.
You can do that in case of multiplication and division only. You're correct.
Okay.
You're not saying wrong. But another way of doing this thing is, first thing is I use the power rule.
Okay.
So what does it become is, it becomes 1 by 4, it throws in front, it becomes log a xy over z cube. What you said was correct too. You're not wrong, Savannah.
But to do it more like efficiently, it would be using the power rule and bringing 1 over 4 to the front.
Yes.
That makes so much sense. And it's like right at the top of my notes. I didn't even like think about it.
For me, the reason I'm saying to do this way is because if it's addition, here multiplication and division you can distribute if you know that. But in case of addition and subtraction, you cannot distribute. So if I have example, if I take your example, if I say you have log base x plus y over z to the power of 4, right? You cannot distribute this 4 in this case. It cannot be equal to x to the power of 4 plus y to the power of 4 over z to the power of 4. This is wrong.
Okay.
So that's why I want to suggest, in case of multiplication, if they're multiplying and dividing, then you can do it.
Okay.
Yeah.
But if it's division, bring it to the front.
Yes, I would say always bring it to the front because it's just easier that way.
Yeah. I can definitely see how messy it could get if it didn't just bring it to the front. So that makes sense.
Now after this, 1 4, okay, you have 1 4.
Okay, we got 1. So then you would do 1 over 4 log a x, I think, minus 1 over 4 or 1/4 log a y, right? Or no, you add it because they're multiplying, and then you would subtract z.
So log a z to the power of 3, right?
Yes.
Okay. And after 1 4, since I'm expanding, I will put in a bracket. Okay.
Yeah.
Because all of them are expanding. So 1 4. I cannot do further this thing. I cannot do further for this thing. What about this thing? Can I simplify this?
The whole expression?
Yeah, log a z to the power of 3. Can I simplify?
Oh, no.
Can I use product?
You could do you could bring the 3 in front of the log a.
So it becomes
Oh my
negative
gosh.
3
This is so much stuff.
log A Z.
Okay,
And now I can open
So-
the bracket.
that's the final answer.
No. I have to open the bracket now.
Oh,
I have to
Okay.
multiply this 1/4 with each and everything.
okay. So then it would be 1/4 log AX minus
Plus.
plus. Would you distribute the 1/4 log A Y and then minus, oh, that's confusing. Would you multiply the 1/4 times 3?
Yes.
So you get 3/4
Yes, correct.
log AZ.
That's it. That's your answer. You cannot simplify further.
Oh my god. Okay, can I have a second to write
Yeah,
all
you
this
can
down?
write
I
it,
had
yes.
to stop writing.
Yes, you can write it.
Okay, thank you.
We'll do a lot of problems on this because this is one thing. You're definitely getting questions on this. You have to use the properties and expand as much as you can. Is Jordan here? Jordan Amari?
Yes.
So okay, so we are gonna do is you're given log A x y z. You have to expand this as much as you can.
Okay, so it's gonna start by log AX
Mm-hmm.
and then plus log AY
Mm-hmm.
plus log AZ.
Okay. Can you simplify it further?
I mean, I don't really know what there is more to say.
No, you
I
cannot
feel like that was
simplify.
expanding it.
That's it. That's your simplification. You cannot simplify. There's no power rule. There's no multiplication. There is no division.
Okay.
So that's your answer. Martin? Is Martin here?
Yes, I was trying to travel.
Yeah. So we have to do this one. Simplify this. Expand as much as you can.
Okay. So, would the 3 and the 4 multiply?
No. So you have 3, Martin. Either you have to use the product rule, either you have to use the quotient rule, or either you have to use the power rule. What you're gonna
Okay.
do?
So right now the power rule.
Okay, so let's see here. Power rule. Okay, if you use the power rule, what does it become?
3 times 4 log A of xz.
No. See here, I'll write the rules here. So product rule I learned was if you have log A m times n. Okay, if they're multiplying, you can separate them. It becomes log A m plus log B n. Okay. Next property we learned is if you have log A m divided by n. If they're dividing, division will change into subtraction. Log A n. Okay. If you have log A m to the power of p, it is to the power of p. I have a power here. The log will pick up the power and throw in front. It will become p log A m. Okay. These are the 3 properties we did here.
Yes, and the third one is the one I was talking about.
If you are saying the third one, okay, if you use the third one, what does it become? Do they have the same power?
The same what?
Do they have the same power? X has 3, Z has 4, right? They are not the
Yes.
same. So let's not use the power rule. Use some other rule and tell me which rule can you use. Are you multiplying anything?
Yes.
What are you multiplying?
X and Z.
So what does it become? Use the product rule then and tell me what does it become.
Log A X3
Mm-hmm.
plus log A Z4.
Yes. Get this thing. Perfect. Now let's see one by one. Can you use any, are you multiplying here or dividing here, or can you use the power rule? What can you use?
I can use the derivative rule.
So what does it become?
3 log AX.
Perfect. And what about the second one?
4 log AZ.
Perfect. Perfect, Martin. If it was whole, then you can take out power first, but if it's not whole, first separate them and then use the power rule.
Okay.
Yeah, good. Let's do one more problem here. Can I have Jordan already did. Sabrina?
Yes.
So you have log A w to the power of 2 x to the power of negative 2y.
Okay. Give me a minute real quick. Would I use the expanding property?
Yes.
Which would be log A w to the second power.
Mm-hmm.
Is that y? Oh wait, x plus x plus log A x to the power of negative 2
Mm-hmm.
plus y.
Plus log A. You have to put log A also.
Plus log A y. Yeah,
Yes.
sorry.
So what does this become? Simplify this further. What can you do, Sabrina?
So do I add?
Do you see anything multiplying here?
Would it be the exponents?
Yes.
2 and negative 2?
So yeah, so what does it become?
Log A.
So let's do one by one. Let's see here one. First log. Are you gonna use product rule, quotient rule, or power rule?
That would be power rule, right?
Yeah, so what does it become?
Oh, okay. 2 log A W.
Yes, correct. For the second one?
Negative 2 log A x.
Yes. And third one?
Log A y.
Yes. That's it. And you cannot simplify further. Good. Okay. So the question, basically let me write the question so that you know on MyLab what kind of question you will get. So the question will be like, for these kind of problems, the question will be express as an equivalent expression using the individual logarithms of w, x, y, and z. So basically they are asking you to convert into individual logarithms. W separate, x separate, y separate using the properties. Okay, Daniela.
Yes.
So you have question log A x to the power of 5 over y to the power of 3z. You have to solve this.
So log A x to the power 5 minus log a y to the power 3 and minus log a c log c.
So what does it become?
And then it's gonna be 5 log a
And then?
x
Okay.
minus 3 log a y and then minus a z.
Good, Daniela. So everyone here, she missed a step, but you can write that step here. What you have to do after minus sign, so it will be minus log a y 3z. Make sure it's in a bracket. When you open after a bracket, make sure you put in a bracket. And then you open and distribute the negative sign. She did it in one step. So make sure you don't do it once. If you understand, yes. If you don't, you can do it step by step. Anyone who wants me to show step by step and did not get how I got this here? Okay, Savannah, you.
Could you do that problem over again, please,
Okay,
or
let's
show it
yes.
step by step?
Let's do step by step for this one. So you had here log a x to the power of 5 over y 3c. First I see they are dividing each other. I see x to the power of 5 and this thing they're dividing each other. Division I know will change into subtraction. Xa, the numerator, minus x log a, sorry, not xa, log a, the numerator, minus log a, the denominator. Anyone has any problem with this one, please let me know what I wrote right now here.
Quick question. What do they say after logarithms in the definition?
2w.
Like is 2w?
2w, x, y, and z. 2w,
Alright, thank you.
x, y, and z, yes. So you, first, anyone has any problem with this step here, what I did here? Next thing is, okay, in the first logarithm, I know I can use the power rule, throw this 5 in front. I get 5 log ax. In the second log, you're like, oh, two things are multiplying each other. Before I taking out the power, because power is just on y. I cannot take out the power first, because power is just on y. First I need to separate them, then I can take out the power. And they are multiplying each other, so I can separate them. Multiplication will change into addition. But make sure, again, important step I told you is, after minus sign, if you are opening, you have to open in a bracket. Multiplication will change into addition. It becomes log a y to the power of 3 plus log a z. You got this? I would suggest simplify as much as you can inside the bracket and then distribute. So this remains as it is. I cannot simplify it further. Minus here. On this thing here, I can use the power rule. This 3 will come in front. You get 3 log a y plus log a z. Now I cannot simplify further. I have to distribute this minus sign. So minus sign in front, just basically what it does, it changes the sign of each and every terms. If this is positive, will become negative. This is positive, this will become negative. If something is negative, it will make it into positive. So you get 5 log a x minus 3 log a y minus log a z. That's a fine answer. That's how she got it. Anyone who wants me to explain this again and did not get this? Let's do one more example. So you have log b xy square over wz cube. Okay. Christopher, Brian, not here. Jose?
Yeah.
Let's see, Jose, how do you do this one?
All right, so you'd expand it, so it would be log x, log x ax. I mean log bx,
Okay.
and then you'd get plus log dy to the second power plus log b to w.
Plus.
And
Wait. Okay, these two are multiplying. So you wrote log bx plus log by square, right?
Yeah.
With whole this thing, this is dividing. So it's not plus. So before doing it directly here, first you see is this and this whole thing, they're dividing each other, right?
Yeah.
Division changes into what?
Change into multiplication.
Division. What is log b
division.
m divided by n? They are dividing. First I want to use the quotient rule. Use the quotient rule and tell me what you get.
Let me go back real quick. So it would be log bx minus
x y squared. They both are in the numerator, right?
Yeah.
So it will be minus log b. What's in the denominator?
wz to the power of 3.
Yes. First you use a quotient rule. Okay. Next, let's see one by one. Let's deal with this first one here. Okay. What can you see? Do you use product, quotient, or power rule?
The power rule?
Do they both have the same power?
No, just y.
So first you have to separate them. Then only you can use the power rule.
So you would expand it?
Yes.
By using the expand rule?
Yes. What does it become?
So then it's log b to x. And then log b and y to the power of 2.
Would I add or subtract?
Subtract.
Multiplication. They're multiplying.
Oh, add, sorry.
Yeah. So it becomes log b y to the power of 2. Then, okay. What about
and
here?
then from there, can you do the power rule, or do you have to also separate the second one?
Second one also you have to separate because there are two things multiplying, right?
So it would be minus log b w plus log b z to the power of 3.
Yes, you are correct. But note, after minus sign you are opening. So what happens? In a bracket.
So you just put log all that into a bracket?
Yes, because after minus sign, if you are opening, always put a bracket. Okay?
Alright.
Okay, let's do this one. Log bx, you cannot do anything about this thing. What about here?
You can, it's plus 2 log b to y. We could use the product rule, the power rule.
The power rule. Here also you log bw. What about here? When I use rule, what does it become?
It becomes plus 3 log b z.
Okay, open the bracket and tell me what does it become.
So it becomes minus do you want me to just tell you the last half of it?
Yeah, last half, yes.
Minus log bw minus 3 log bz.
Perfect. That's it. Any questions, anyone? Okay. So the one last problem for this type of question I want to do is, if you have log a, then you have this x to the power of 7 over y5 z8. If you can do this thing here by yourself, that means you got the problem. If you can do this, I want everyone to try these problems by themselves so that you can check you understood the problem or no. This type of question covers everything. Rado? Rockwell? Rockwell?
Yes.
So Rockwell, how do you do this one?
This one. That's all that's under the radical.
So everything is underneath the radical. So let's write the whole thing as something. What does it become?
Log A. And then, yeah, X. And then would you square that, right?
Yeah, so what's the power? What will be the power here on the top?
Yep.
What radical is this? Is it cube root, square root? What is it?
That's square root. I just said 2.
Yeah, 2. So it will
Am I
be
lagging?
1 over 2.
Oh, no, that's 10. My bad. That's 10. 10. Sorry, 10.
No, it will be 1 over 2. You're correct. It's 2. It will be 1 over 2.
Wait. Okay, so it's 2. Yeah.
Yeah, it's 1 over that number. Okay? So,
wait,
okay.
What? All right. Cool.
What's the first property you're going to use?
Don't you have to? So that's the reverse of something. I'm trying to remember what it is.
Which rule? See, you have to, Rockwell, you have to 3 rules you had. Power rule, product rule, quotient rule. What do you see? When you see this question, what's the first thing you see?
I see 7 and 8.
See,
but
7.
No common terms.
See
no common terms.
all of this thing has power as 1 over 2, right?
Yeah, but inside the parentheses, there's nothing, there's no exponents under the sign or anything.
Yeah.
Nothing.
So let's see here. First, how do I get rid of this 1 by 2 power? Which property can I use?
Can you use the quotient rule?
Quotient rule. I'm saying only think about this 1 by 2. 1 by 2 in the power. This whole thing is the power.
Yes.
So if you use the power rule, what does it become?
X. Oh.
What does power rule do? What does it do to the power? The power rule. It throws it in front, right?
Yeah.
So what does it become?
I'm only hearing like half of what you're saying. I'm like.
So what I'm saying is we have to use the power rule in this. Okay?
Yeah.
What does
Okay.
power rule do? It picks up this power and throws in front. If it throws in front, what does it become?
Throws what in front?
This power here, this power. So it becomes 1/2. It will pick up this power and throw in front of the log. It becomes 1/2 log A x to the power of 7
okay.
over y5
That's what I was thinking.
z8.
That's the inverse of something else. That's what I was talking about. That's okay. Gotcha. So just put in log form.
Yes.
Okay.
Once you got this thing, okay, we have 1/2. We have 1/2 already in front of this whole thing. And now we are expanding. So I'm going to expand in a bracket. Okay. Now you do. Which property you're going to use first? Product, quotient, what?
That 1/2 log A. Is it? Well, wouldn't you take the 1/2? No, you would leave that.
1/2 is outside.
I don't know what you would do in this step of the problem. Like that. I don't know.
Okay, which property? Are you going to use quotient? What are you see? Do you see anything dividing or multiplying each other?
I mean, they're dividing, but it's not even.
No,
Like,
it's okay.
not-
It's dividing. Let's separate it by division. Division changes into what?
Subtraction.
Subtraction. So I have log A, the numerator, the top one, minus log A, the bottom one. You get y5z8. Okay. Now, do you see anything multiplying each other?
Yes.
What are multiplying each other?
Y5 and Z8.
5 and z8. But note, it's after minus sign, right? So I'm going to put
Okay.
one more bracket inside. Okay.
So just the log stays negative, and the rest you have to put parentheses around it to make sure it's positive.
So how do I separate them?
The extra bracket.
log 8. Multiplication changes into what?
Subtraction.
Division changes into subtraction. Multiplication changes into
Addition.
addition. So it will be log a y to the power of 5 plus log a z to the power of 8. Okay, you got this now.
I'm sorry to interrupt, Professor, but the log, is that an 8? Where did the log 8 come from? Yeah, I'm kind of confused on that too.
Log 8. Oh, sorry, it's a. Oh, I'm sorry, guys. It's a. I'm sorry. It's a. It's 8. Thanks for correcting me. Yeah. So now here, Rockwell, okay, I have log a x to the power of 7. Do you see any in this log only? Do you see anything multiplying each other?
No, not right there. I mean,
Do you see
that's,
division?
that's a power.
Yes.
If you want to count that as multiplying multiple times, then yeah.
So what does it become? A power rule. How do you use a power rule?
Is it? Well, that's not negative, so
What does power rule do? Power rule picks up the powers and throws
oh,
in
okay,
front.
yeah. So 7 log a x.
Perfect. What about this one? In this one, what does this become?
5 log ay, or negative 5 log ay.
Yes. And what about this one?
Log, or no, what is it? 8 log az.
Az. Okay. Now let's open bracket. Let's open the inside bracket first. When I open the inside bracket, what does it become?
Side 1/2 7 log a, or 3.5 log a.
Okay. And what does minus sign do?
It just changes the sign.
There will be minus 5 log ay minus 8 log az. Okay. Now I have to multiply half with everything. What does it become?
3.5 log a x minus 2.5 log ay minus 4 log az.
Correct. That's it. That's your answer. Good, Rocco.
Thank you.
So these are the problems you're going to get where you have to expand. Now there could be problems like where you have to write as a single log. Example you are given is, example like a, you're given half log ax minus 7 log ay plus log a z. Dylan?
Yes.
Let's combine one by one. Okay. Let's take first two. Combine and tell me what does it become.
I got, is it?
First, you will always get rid of this number in front. How do I get rid of this number?
Oh, you make it log a x, I mean square root x.
Yes, x to the power of 1 by 2. Okay. What about this side? What does it become?
And then minus log a y to the 7th.
Okay. And this remains log az.
Yeah.
Okay. Let's combine these two first. What does it become?
That would be log a, then in parentheses, x to the 1/2 over over y to the 7th.
Okay. Then you have plus log az. Now let's combine these two again. What does it become?
Would z just go in the denominator?
It's addition, right?
Yeah.
So addition changes into?
What'd you say?
What does addition change into?
Say that again.
Whenever, so you're adding, right? You're adding here, right?
Yeah.
So addition will change into what?
Oh, multiplication.
Multiplication. So you're going to multiply this whole thing with z, right?
Okay.
Which is basically z over 1.
All right.
So what does it become? Log a
log A,
You just
and then
multiply like this.
square root x z
Yeah, over.
y to the 7th
That's it.
times 1, or just y to the 7th.
Y to the power 7. Anything multiplied by 1 is just the same thing.
Yeah.
Yeah, that's what you get your answer as. Good.
Okay.
Julian?
Yes.
Okay, so Julian, next problem you're given is, you're given log a b over square root of x plus log a square root of bx. You have to write as a single log.
So I'm still kind of, honestly don't know. It's kind of confusing.
So here, see here. First of all, addition, right? Addition will change into what?
Addition will change into multiplication.
So what does it become? Log a
Log a. What am I just combining them? I'm
yes,
kind of
combining
confused.
by multiplication, right? Because it's addition. So you have log a this plus log a this. So when you combine, it becomes log a. Addition will change into
I'm not sure.
You said addition will change into multiplication. So just multiply these two. What does it become? B over root x times root bx. Okay? You got it or no, Julian?
I mean, it's no, I don't.
So see here.
Pretty confusing. I don't.
So the property is, Julian, the property is log am plus log an is actually equal to log a. If it's addition, you can combine back, they will multiply each other. That's a rule. Okay?
Okay.
So here I have log a this whole thing plus log a this whole thing. They're adding each other. I can combine into one log. Again, log a, my base will still remain a. But I can multiply these two things. Do you get this step or no?
Yes.
Okay. Next thing is, we need to simplify here. You have log a, basically you have, if I combine them, it becomes b bx, because it is basically over 1. When you multiply, you just multiply directly like this. You get this thing over root x, because anything multiplied by 1 is the same thing. Note, in the numerator also I have root x, in the denominator also I have root x. So they cancel. I'm left with just b root b. And that's my final answer. Or you can do it is b root b is basically log a, b to the power of 1 and b to the power of, what is root? How can I write this as power, Julian?
How could you write it as a power?
Yeah. I want to write something here. What should I write? Square root as?
This, I'm not sure.
It's 1/2. If there is a number square root, it's 1/2. 1 to the power of n. And which basically becomes, we did this property before in case of same base, different exponents, you add them. So it becomes b to the power of 1 plus 1/2, which is log a b to the power of 3 over 2. And power will be throw it in front, you get log a b. That's a final answer. You convert it into final. Make sure you're very firm with these properties. Today's homework is all about these 3 properties. Make sure you know how to use these 3 properties really good. Next property is the logarithms of the base to an exponent.
Esther, I have a quick question. So where you say log a b to the power of 1 plus 1 over 2, and then you get log AB 3 over 2. How do you get 3?
Okay, so 1 plus 1 over 2, right?
Uh-huh.
For that thing, you need to have the same base. I need to make this 1 as some base with 2. Can I?
Okay, right.
Multiply
Got
by
it.
2, yes.
Okay, thank you.
Yeah, no problems. So the next property says if you have log, we already did this property, I already told you, if you have log a to the power of k, note my base, and then the same base is raised to power some power. Note here I have some base, and that same base is raised to power some power here. Then in this case they cancel, your answer will be just k. Example, if I say what's the value of log 3 to the power of 7? Note my base here is 3, and here I have that base to the power of something, the same number to the power of something, same as my base. Basically they cancel, your answer will be just 7. Example one more, if you have log 10 to the power of negative 5.2, you have 10 to the power of negative 5.2. Caesar, what will be the answer for this one?
Negative 5.2.
Yes, they basically cancel and you're left with negative 5.2. I want everyone to try these problems right now. Okay, you will have 10 minutes break. You will have 10 minutes break, and I want, if people who want to stay back, want to practice problems, can stay back. 10 minutes break. I'll see you at 11:10. See you guys at 11:10. But people who want to practice, please stay back. Anyone who wants to practice here?
Yes.
It is Jordan? Oh,
Yes.
Okay, Jordan wants to practice. Anyone else here? Okay.
I'll practice.
Okay.
I'm here. I'm just looking to listen.
Okay, Chanthan is there, Jordan is there. Who else is there?
Julian.
Okay, Julian. Okay, so let's see here. I give you a problem here is you have, let's do with simple problems. So you have log ax plus log a3. You have to combine into simple log. Do this problem right now and give me an answer. I'll call you guys' name and then you can give me. Try these problems yourself. We'll do these problems first. Chanthan, are you working?
I'm here. Can I just listen in?
Okay.
Is that okay?
Yeah, it's okay. Yeah. Okay, so Jordan, what do you think for the first one?
So I was looking back at my notes, and can we multiply the x and the 3 together?
Okay, what does it become?
Log a 3x.
Yeah, so you had log a x plus log a 3. Since your bases is the same, you can combine, it becomes log a 3x.
Yeah.
Correct. Okay, Julian.
Yes.
So you have log AC minus log AD.
So would that be log AC divided by D?
Yes, correct. Absolutely correct. Is there anyone else? I know Jordan and Julian and anyone else working? Sabrina? You're also working
Yes.
on these problems?
Sorry, I was copying number 2, but yes, I'm working.
Okay, so you have 8 log AX plus 3 log AZ. How will you work on this?
So for that one, do we combine the numbers, like add them, or?
See here, first thing is I cannot combine these two. The reason the top ones I could combine, I had log something plus log something, I combined. But in this case, I have a number in front of the log. Right?
Yeah.
How do I get rid of this number? Note, we have only 3 properties we learned so far. Product rule, quotient rule, and power rule. Which thing helps you to get rid of this number?
The power rule.
The power rule. What does power rule will do? It will take it back on the power.
So it would be log a x to the power of 8.
X to the power of 8.
And then the other one would turn into log, or it would be z to the power of 3, I'm sorry.
Yeah, z to the power of 3. Now, Sabrina, what does it happen? What do you do?
I'm not sure.
Can you multiply them now?
Exactly. Now you have log am plus log am. Now
Okay, so it'd just be log a x to the power of 8, z to the power of 3.
That's it. So if you have a number in front, throw it back in the power and then combine. Are you getting it, Sabrina?
Yes. Yeah, it makes more sense now.
Okay.
I don't know why I thought we were supposed to multiply them, but yeah.
You're correct. We are multiplying. It's just that first we need to get rid of this number in front. Okay?
Yes.
Let's do one more problem. So you have 2 log bm plus half log bn. Okay, Jordan.
So log bm plus.
So first, I'm gonna use the power rule, and it's gonna be log b m2 plus log b n1/2.
Perfect. Then what you're gonna do?
Then we're gonna multiply that, and that's just gonna make it log b mn1, or no, m2 and 1/2.
Yes, exactly. That's it. You cannot combine because they are different numbers. M is different, N is different.
Okay.
Yeah. Let's do the 5th problem here. So the 5th problem was 2 log bw minus log bz minus 4 log by. Now, I want everyone to mark this problem as important here. Mark this problem as important here. Okay, Julian, what do you think?
So we'll start off by log bw squared.
Minus log bwz. What about this one?
And then the other one will turn into log by to the 4th, to the negative 4th, I'm sorry.
Just 4. Let's keep minus sign there only. I don't want to take negatives up. Okay. Then what happens is, okay, in this case, everyone, very important step here. Since you have 2 negative signs, I would suggest you to take out the negative sign common. take out the negative sign common. Very important step here. When you take out the negative sign, basically it will change the sign of both of these. It will make it positive. It becomes log bz plus log b y to the power of 4. Now Julian, can you tell me what does it become?
1 second. So then you just distribute the negative?
No, we don't have to. We just took it out negative. Now you combine these two.
Okay, so it would be log b z y to the 4th?
Yes. In this question, what we are trying to do is we are combining into one log. We are not expanding. Previous example, we were expanding. We wanted it as big as we can. In this case, we are condensing it. We are making into one log, single log. Now, let's open the bracket. Julian, what does it become?
So it becomes negative log b zy to the 4th?
Okay. Now,
Minus?
combine and what does it become?
Is that the final answer?
No. You have to combine into single log.
Oh, okay. 1 second, let me just write it down.
They're subtracting. Do we divide?
Yes, exactly. Log b, the first one divided by the second one. Correct.
So it'd be log b w squared divided by z y to the 4th. Okay.
Yes, exactly. Yes. Let's do one more problem here. Last problem here is, so you're given 2 log b w minus log b z. Oh, we did this problem already. So let's do another one. You have 3 log c p plus half log c t minus log c 7. Okay, Jordan. Sabrina, you want to do this?
I'm gonna try.
Okay.
Can we do part by part?
Yeah. First, let's do one by one. Let's get rid of these numbers in front.
Okay.
So what does it become?
So that's log c to the power of 3.
P to the power of 3. Okay.
Is the p with it?
There was a p, right? Here, p. See here?
Yeah. Oh, okay.
So that will become to the
Log
power of 3.
c p to the 3rd. Okay.
Then log c
Plus log c t to the power of 2.
1/2. 1/2.
1/2.
Yeah, there's
Okay.
number 1/2, right? So that whole thing will go. Okay. And then minus this does not have any number, so it stays as it is. Okay. Do you
And then it
see
keeps going.
Do you see 2 negative signs, Sabrina?
2 negative signs? No.
There is only one. In previous example, I had 2 negative signs, right? I had 2 negative signs. That's why I had to take out a negative sign common. But in this case, I don't have it, so I don't have to take out anything common. What will I do is, I'll start combining. Let's combine these two first. What does it become?
It would be log c. Would it be pt and you would combine 3 times 1/2?
Yeah, t times 1/2, because multiplication, addition changes into multiplication.
Multiplication.
Correct. And then you have minus log c 7. What's the next step?
Would that be log c? You multiply 3 and 1/2?
No.
The power of 3
The thing is,
and 1/2?
they are
or
different,
Does that
right?
stay the same?
They're different. P is different, T is different. So I cannot do it. They remain as it is. I need to combine. How do I combine? I want
Since it's
one log.
subtracting, would you use the quotient
Yeah, it will
rule?
be division, quotient rule. Subtraction changes into
Oh, okay, the quotient rule. So it'll be P3 MT 1/2
divided
over log C7.
by just
Okay.
7, just 7.
The 7?
Yeah, just 7.
Oh, okay, yeah. Log
Yes, come on.
it's on
Yeah.
the side. Okay.
Not the final answer.
That's a final answer. Or if you want, you can convert into P3 and then this will become square root of T over 7.
Okay. And both are correct to write.
Yes, both are correct. Yes.
Okay.
Okay. So everyone here, okay, till the time you guys try these problems here. Who was practicing before? Is everyone back here? Okay.
Yeah.
Yes. Yep.
Okay. Christina, I want everyone to start doing these problems here. The problems which are written here, I want everyone to do these problems. In your exam, the coming exam, we are almost left with only 2 exams now. No, yeah, no. Yes. We are left with only 2 exams so far and then a final exam. And this exam will definitely have problems on this, what you are doing right now. Expanding and condensing. So in this case, I want your answer in 1 log. I want you to combine and convert it into 1 log. You're definitely gonna get in your exam problems like these for sure. So make sure you do these problems really good. I'm just focusing today on these problems. Okay, Christina?
Yes.
The first one, what do you think? How can you combine?
It will be log A 3x.
Log A 3x, correct. Martin?
Yes.
What do you think about the second one?
Log AC divided by D.
Perfect, perfect, perfect. Okay. Can I have Savannah?
Hi, sorry.
Yeah.
So which one? Number 3?
Number 3.
Okay. Log A K equals K. Okay, so you'd get log I don't know, log 8 or log A.
First, get rid of this number.
Oh, there's an X in there.
First,
Sorry.
how do you get rid of this number?
It would be the exponent over X, right?
Yeah, exactly.
So log A X to the 8th.
Plus log A.
Plus log A Z to the power of 3.
Now you combine. What does it become?
And then you'd get log A X to the 8 times Z to the 3.
Perfect. That's it. You got it, Savannah.
Oh, sweet. Thank you.
Yeah. Good.
Okay.
Professor, I have a question.
Yeah.
So I know I've asked you about practice tests before, and you said our practice should just be the homeworks. But for the final exam, I feel like everyone would do better if we had some problems that could prepare us for what we'll face in the final exam. And I feel like we'd do better if we had practice tests. So if possible,
final exam will be doing a lot of review. We have 2 days of review for the final exam.
Okay.
For final exam, we will be going through a lot of reviews. So 2 days, basically, we will be doing everything. And you will not have the whole syllabus. I will cut it short to, some topics only. I don't want everything.
Okay.
Yeah. But definitely these logs, what we are doing, the properties of logs, these are definitely coming in exam. Final exam also.
I just want to add on to that. That's awesome that we're going to do 2 days of review.
Mm-hmm.
I think it, like agreeing with what she's saying, it could be helpful though, like to have just even like a little practice test on the Mayan Pearson Math Lab, just so we know the exact format that they want in case.
I'll do that. I'll do that. I'll time it and then, so that I can give you the timing and then you can practice the same kind of problems. Yes, I can do that.
Awesome. Thank you.
I'll do that. Yes. Yeah. So, okay. 4th one, can I have Daniela?
Yes.
How do you do this one here?
Wait, did you call me?
Yes, yes.
Okay. So that's log B M square.
Mm-hmm.
The power of 2, I mean. Yeah.
Then?
And would this be like the thingy? I forgot what it's called.
So let's see. If you take this also back to the power, what does it become?
N
To the power of?
half.
Half. Okay, when you combine back, what does it become?
It become log B M square power of 2 and N times 1
1/2.
and 1/2.
Yes. And 1/2 is basically, it's a square root with a 2 number here. Good, Daniela. Brian is not here. Jose?
Yeah.
Okay. Jose, so
For
this
number 6.
for number, we are doing number 4 now. No, actually number 5.
Number 5? Okay.
Okay, number 5
So
is very important.
it would, for number 5, would it be log BW2 to the power of 2?
Okay.
And then you'd have, would it be plus or minus log B?
Minus,
So-
let's leave it there.
So minus log BZ,
BZ.
and then you have minus log B y to the power of 4.
Okay, you got this thing. Now here I want everyone to write important here, because we are going to do an important step in this one. Whenever you see two negative, once you use the power rule, put everything back to the power, I want you to notice if there are two negative signs. So if you want to make a note, if two negative signs, take out negative sign common. So you're gonna take out negative sign common. So I see two negative signs. I will take out common now. So what I'm left with inside, Jose?
It would be log BZ and then plus log B to y to the power of 4.
Okay. Now, can you combine the inside one?
No.
You cannot?
No, because they have different bases and...
They have the same base, BB.
Oh. So it would be log BZ and then y to the power of 4?
Yes. Multiplication, addition changes into multiplication. Then what's the next step? Open the bracket. What does it become?
So it becomes log BW to the power of 2 minus log BZ times y4.
Okay, when you solve, what does it become?
I'm not sure what to do next.
Subtraction. Same base, subtraction. How do you combine?
So I'm not sure what it'd be.
See, addition changes into multiplication, right?
Yeah.
Subtraction changes into division.
So we would put into division, it'd be log BW2 over log BZY
Not log,
to the power of 4?
Just zy to the power of 4. You're combining. So log will come out only once.
Is that just the answer right there?
Yeah, that's your answer. That's it. Yes.
Alright, I'm just going to write everything down now.
Yeah. This is a very important kind of problem. You will definitely get a problems on this either in your final exam or you will get it in your test also, or you can get in both also, where you are taking the negative signs common or you are putting a bracket in front of the negative sign. These are something you are definitely getting problems on this. Let's do one more problem here. So you have Dylan here. Dylan,
Yes.
so you have 3 log CP plus half log CT minus log C7.
So I did. It would be log CP to 1/3.
Just 3. There is 3 only.
Oh yeah,
right?
just my bad.
Okay.
Then plus log CT to 1/2.
Okay. And this remains log C7.
Yeah.
Do you see 2 negative signs here, Dylan?
Only one.
Only one. So I don't have to take out common. In case there were 2, I need to take out minus sign common and put everything else inside the bracket.
Mm-hmm.
So let's just combine 2. Let's combine these first 2. What does it become?
Log C P to the 3rd T to 1/2.
Perfect. Minus log C7. Now we'll combine these 2. What does it become?
You want me to combine the P to the 3rd T to 1/2?
No. Log C, when you set minus log
Oh,
C.
P to the 3rd T to 1/2 over 7.
Yes. You cannot combine them since they are not the same. If I had t to the power of 3, t to the power of 1/2, then I can combine. But one is p, one is t. They are not the same. I cannot combine. And square root I can write as what? 1/2 I can write as?
Square root T.
Square root T over 7. So that's a final answer. Good. Caesar?
Caesar.
So you have log a x square minus 2 log a square root of x. Let's write square root as half fraction.
Yeah. Can we, for the minus 2 log a square root x, can we make that?
How do I write here? How do I write square root as?
1 over 2.
1 over 2. Okay. Now let's do problem. Okay. What's the first thing I'll do, Caesar?
Wow. I'm not quite sure. So would you, it's minus, would you put it over another?
You cannot do it because there is a number in front.
Okay, so you'd put the 2 or negative 2 times 1 over 2?
Let's keep negative here only. We don't have to take the negatives, just a number.
Okay, so 2 times 1 over 2?
Yes, correct. And you multiply it with that thing. Okay. Which becomes what? What is 2 times 1 over 2?
1.
Just 1. Yes, which is 2 over 2, which is just 1. Okay. Now you can combine it because I don't have any number in front.
Okay, got it. So becomes log a, then x squared over x.
Perfect. Which is equal to what?
Just x.
Yeah, exactly, x. Because in the numerator, x squared means there are 2x. In the denominator, there is 1x. They cancel, you're left with just x. or if you want to write the properties we used here, is if you have a to the power of m and a to the power of n, my base is same, then you subtract. And if you have same base, this thing, you add the exponents. Since my base was the same and different exponents, division, you subtract. So you got 2 minus 1, which is log a x. Any questions, anyone, till 7th problem? Before you go, I want to do 3 more problems and then we are done for today. Is okay, first problem is you have to do log a 2x plus 3 log a x minus log a y. Try this problem. Is Cat here?
I'm here.
Yes. Combine into one log.
Just so that you know, I've been struggling with this one a little bit. This topic that we're doing.
It's okay.
So I'm
I'll
gonna
help
try
you.
my best. And also, my brother's playing his instrument in the background, so if you hear that.
It's okay.
Would you use the distributive property?
Yes, correct.
I don't really know how to do 3 times log.
So you just write 3 times log, that's it. You don't have to multiply, just write it.
Okay, so 3 times log ax minus 3 log ay.
Perfect. You just write it. You cannot multiply, you just write it.
Mm-hmm.
Okay. Now I need to combine them. What you're gonna do?
You can't combine. Actually, you can combine the log a's, right? You can combine all of them, or no?
I can combine because they all have the same base. But you know, Cat, what's the problem? I cannot combine till the time I have these numbers in front. I cannot have these numbers in front.
Okay.
How do I deal with these numbers?
Would you multiply inverse? I'm not sure.
So whenever you have this number in front, you put it back in the exponent. Use the power rule and put it back in the exponent.
Okay.
So first one will remain as it is. This one has a number in front, right?
Mm-hmm.
So it becomes log a, and this 3 will go and will become the power of x.
Oh, okay.
You tell me what will become for this one. Minus
Log a y3?
Yes, correct.
Okay.
Now since I don't have numbers in front of log, I can combine. I can start combining. Okay.
Okay.
First of all, do you see any 2 negative signs, Cat?
I only see 1.
1. Since it's 1, there is not a problem. But if there is 2, I need to take out the negative sign common. Mm-hmm. But since there is 1, I don't have to worry. Let's combine one by one. Let's combine first 2. What is yeah.
Would that be... How would I combine that?
Addition. Addition changes into?
Multiplication.
We use 3 properties: product rule, quotient rule, power rule.
Mm-hmm.
Which one are you going to use? I'm going to write here, product rule says if you have log am plus log an, okay, you can combine it and write it as log am times n. You can multiply them.
Okay.
If they are subtracting, then you can combine and they will divide each other.
Okay, so it would have to be log a 2x times x to the 3rd?
Exactly, yes. Okay, minus log a y to the power of 3. Okay.
So it would end up, we would have to use the other type of, so it would be log a y to the third over.
No. First this one.
Oh.
First this one, and after minus what you have, that goes at the bottom.
What do you mean first this one?
Okay, like you log a m, then you have minus log a m, right? So m comes on the top, and n after the minus log, whatever is there, that goes in the denominator.
Okay.
So after the minus, I have y cube, right? Y to the power of 3 will go in the denominator. Okay. But we need to simplify. What is x times x cube?
X to the 4?
Yeah, x to the power of 4 over y cube. That's it. That's a final answer.
Okay. Yeah, I'm just saying that a little bit.
For the final, so for the final answer, does it always have to be in parentheses with the fraction?
No. You don't have to put a parentheses. No.
Okay.
You just write it like this. Yeah. Okay. One more question I want to do is if you have log a x plus 9 log a 5. Let's say log a 9. You're given this problem here. Jordan, Paulo, Lauren.
Yes.
So how do you solve this one?
So we're first going to start off by, I'm just going through here. It's going to equal, we would put 9 in front of log a.
No. We got 9. No, because there is no power here. If you have a power, do you have 9 to the power of 3 something?
Oh, okay.
We don't have to do it. In this case, you have log a something minus log a something.
So I'm going to have
log a what? How can you combine? Subtraction changes into?
Into an exponent.
See here. Addition here. Addition, when you combine, it becomes multiplication. Addition when combined becomes multiplication. Subtraction when combined becomes division. Are you getting it, Lauren?
So we're going to be dividing?
Yeah, so it becomes x plus 9 over 9.
9.
That's it. That's your answer. Cannot simplify it further.
But we can't cancel the 9s out.
Yeah, you cannot cancel. If they were multiplying, you could have cancelled, but since they're adding, subtracting, you cannot cancel.
Okay.
Yeah. So remember here, addition when combining, addition changes into multiplication, subtraction changes into, okay, so when you can say, if you want to write it in words, when combining, so changing in combining, addition changes to multiplication. When combining, that means you're making into one log. Combining, negative changes in subtraction changes to division. When expanding, now you're given 1 and you're expanding into more. Multiplication changes to addition. When expanding, so you're making into 2 now. Division changes to subtraction. Make sure you remember these laws. Any questions with today's lecture? Anyone? Okay.
No.
Okay. So the people's attendance, whose attendance I don't have. is Brian, Gerardo, Jordan Paulo, Niza, Yasmin, Maria, Anthony, and Carlos. Everybody else attendance I have. Thanks guys. See you.